Welcome back to Generative AI 101, the podcast where we turn the dense jungle of AI and generative AI into a delightful, leisurely stroll. I'm Emily Laird, your guide through this wonderful world of pixels and parameters. Today, as part of our deep learning mini-series, we're diving into convolutional neural networks, or CNNs, those superstar athletes of the neural network world. Ready to get your brain cells moving? Let's get into it. Welcome to Generative AI 101. All right, let's talk CNNs. Imagine you're at an art gallery, but instead of being overwhelmed by abstract paintings, you've got a robot that can analyze every brushstroke and tell you what the artist had for breakfast. That's CNNs for you. They're the art critics of the neural network family, especially good at understanding and interpreting visual data. All right, so what are convolutional neural networks? CNNs are a class of deep neural networks primarily used for analyzing visual imagery. Think of them as the eagle-eyed inspector at the airport security, scanning your luggage for any hidden contraband, but instead they're scanning images to detect patterns, objects, and features. They're designed to automatically and adaptively learn spatial hierarchies of features from images, which makes them perfect for tasks like image recognition and classification. So what are some key concepts of CNNs? Well, the first is convolutional layers. So these are actually the heart and soul of the CNNs. Imagine a tiny, magical magnifying glass sliding over your image, one small section at a time, capturing the essence of each part. This magnifying glass is actually a filter or kernel that detects specific features like edges, textures, and colors. It's like your nosy neighbor peering through the blinds, noticing every little detail. Then we have pooling layers. After the convolutional layers have done their thing, pooling layers step in to simplify the information. Think of it as taking a high-resolution photo and shrinking it down to a manageable size without losing the important bits. Pooling layers help reduce the dimensions and the amount of computation, kind of like packing your vacation suitcase efficiently. Only the essentials make the cut. Then we have fully connected layers. These layers take the pooled data and combine it to make a final prediction. It's like gathering all the clues from a mystery novel and figuring out who the culprit is. These layers help the network understand the bigger picture and come up with a conclusion, like deciding whether the image is a cat or just a very fancy throw pillow. So let's break down how CNNs work with an example. Imagine you want to teach a CNN to recognize pictures of pizza. You feed it thousands of images of pizza. I know, tough job, but someone's got to do it. The convolutional layers scan these images, detecting features like crust edges, cheese blobs, and pepperoni dots. The pooling layers simplify these features, and the fully connected layers put it all together to decide, yeah, this is indeed pizza. Each layer in a CNN acts as a different stage in a detective's investigation. The first layer might detect simple edges and shapes, while the deep layers start to recognize complex patterns like toppings and even the type of crust. It better be stuffed crust or take it back. By the end, the CNN can look at an image and confidently say, that's a pepperoni pizza from your favorite joint down the street, which is Casetta's in St. Paul. I'm not joking. Recommendation. So let's look at some real-world examples of CNN because they're not just about pizza, though that's important stuff. They're used in a variety of really cool and practical applications. So think image and video recognition, right? So CNNs power the facial recognition software that unlocks your phone. It's like having a bouncer who knows your face and lets you into the VIP section. Very critical for keeping snoopy eyes out of your device. Then let's float into healthcare, medical imaging. CNNs help doctors detect tumors and other anomalies in X-rays and MRIs. It's like having a super advanced magnifying glass that spots issues your naked eye might miss. Then there's art and creativity. CNNs can even create art, turning your doodles into masterpieces or generating new, never-before-seen works. It's like having Picasso as your personal art tutor. Of course, CNNs aren't without their quirks. They require a lot of data and computational power. Training a CNN can be like training a cat to do tricks. It takes time, patience, and a lot of treats, or in this case, data. Let's not forget the times when CNNs hilariously misidentify things, like calling a picture of a toaster a guitar because of some random pattern they picked up along the way. In summary, convolutional neural networks are the Sherlock Holmes of the AI world, dissecting visual data to understand and classify images with remarkable accuracy. They power everything from your smartphone's face unlock to advanced medical diagnostics, making our lives smarter and more efficient. That's all for today's episode on CNNs. I hope you've enjoyed this deep dive and had a few laughs along the way. If you've got questions, thoughts, or just want to connect, find me on LinkedIn, Emily Laird, Laird. Let's keep the conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about convolutional neural networks now than you did when you arrived.